right there for you. And the neuropod code is right there as well, CTGDN. So go ahead and get into that neuropod and calculate the dot product of each pair of vectors. Good morning, Sarah. Good morning. Good morning, Sarah. Sorry. Good morning, Brianna. All right. Let's see. All right, so remember, I see a couple of people just adding the vectors together. Remember, the dot product is you multiply the x's together, multiply the y's together, and then you add them, right? So you should end up with a number, right? So you multiply both x's, multiply both y's, and then you add those two numbers together. Right? You guys doing okay? So for the first one, for example, -4 times 5 plus 4 times 3. Good morning, Trish. All right, looking good. I'm going to give it one more minute. I see a couple of people submitted. Good job, good job. All right, don't wait for me. I want you to try it. I want you to give it a try. You don't have to wait for me to go over it. I want to see if you can do it. All right. All right, so let's talk about the first one real quick. Well, actually, the first one, actually, yeah, no, we'll go over it. So let's talk about the first one. So if I have that first vector, I think everybody for the most part, I think everybody got that, right? So the first vector was vector A in the direction of -4, 4. And we had vector B in the direction of 5, 3. And again, the dot product is just multiply the x's, multiply the y's, right? Multiply the x components, multiply the y components, and add them together. So here's your first x and your first y. Here's your second x and your second y. So again, the dot product, the idea of the dot product is it's the projection of one vector onto the other. So you multiply the x's, multiply the y's, and add them. So -4 times 5 plus 4 times 3. So -20 plus 12. So that would be -8. That would be -8. Right. Any questions with that? Any issues or concerns at this point with it? Right, and so for the second vector, you should have gotten 0, -16 plus 16, which I think most people got, and a couple of people actually made a note that that is orthogonal, that pair of vectors is orthogonal, which is a good point. That is true. And then for the last one, 6 times 7 plus 7 times 6, so that's 42 plus 42, so 84. So -8 and 0 and then 84. Okay. All right. Any questions about that slide or the warm-up? So remember, the dot product is a number. It's not another vector. It's multiplying the x's, multiplying the y's, adding them together. It's projection of one vector onto another. Okay. Okay, I'm going to slide you forward in the Nearpod and we'll talk about what we're doing today. So today we are going to use dot product to find the perpendicular components of the vector. Okay, so we know how to find a dot product, but now we're going to use that dot product formula to find a perpendicular vector, or what we know about perpendicular components of a vector. Okay. Okay. So you did a warm up. We're gonna do some notes, guided practice, and then we might play a game. I'm gonna see how we do. We might have time to play a game, but we'll see. And then summarize and close. And you're gonna have to tell me if we do get to play the game, you're gonna have to tell me what you think of the game, if you think it's worth doing again, because it's a little bit experimental. So we'll see how it goes. All right, your week 5 homework has been published. I'm gonna publish the week 5 formative after today's class, and both are due next Wednesday. All right, and then weeks 1, 2, 3, and 4 are still open, right? So we have basically a total of 10 assignments, 5 formatives, 5 homeworks, right? That will be published by the end of today. So please make sure you do them. And then you'll need Zoom, Nearpod, a scientific calculator will be helpful, and your formula sheet will be helpful. Just a quick announcement, the grades have been updated. Grades are updated. So if you look in Synergy, that's what the grade is, all right? I've graded everything, things are updated. So please take a look at those grades, see what you're missing, see what you need to still get a handle on, and let's finish strong. Seniors, you have 7 more days, right? Everybody else, I think we have something in the teens. All right, questions? Anything? All right, so let's start using dot products to find perpendicular components of a vector. So we remember the formula from the warm-up, right? U1 V1 plus U2 V2, which is the same as, you know, x times x plus y times y, right? So this is a review from last class. And so now what we're going to do, and I'm going to do this in the Zoom, we're going to find a vector that's orthogonal to another vector. So we know how to find the dot product, but how do we find a vector that's orthogonal to another vector? Okay, so we're going to do two things. First, I'm going to show you how to do this thinking about it with a graph. And then I'm going to show you how to do it, how to find just one component. So basically it's two things, right? So if you look up at the, turn this light on. So if you look up at the Zoom, and if you're in person, you can look at the Promethean board. We have find two vectors orthogonal to each of the given vectors. So again, orthogonal is perpendicular. That's that vocabulary word we learned last time, right? And so we have a vector in the direction 2, -7. So we could plot that 1, 2, and then down 7. Okay. So that's vector, this is vector V. It's the V. All right. And we need to find two vectors that are orthogonal. So that's going to be at a 90-degree angle. Okay. You might have taken Math 8 or you might have taken IM, but if you're finding something perpendicular to a segment, right, you basically can switch components and make one of them switch signs, right? So if you were using approach or a compass and looking at like a real 90-degree angle, you would basically see that you would have one 90-degree angle would appear. So this is 2, -7. One 90-degree angle would appear at 7, 2. And then another one would appear at -7, -2. Okay. -7, -2. So those are the two vectors that are perfectly orthogonal to the original vector, right? So one vector we would find at 7, 2 in the direction of 7, 2, and the other one would be in the direction of -7, -2. Okay, so this was our original, right? This vector V, right? And to find the two vectors that are perpendicular to that original, I switch the components and then switch one of the signs. So if my original vector was 2, -7, now I have 7, 2, and the 7 switches signs, okay? For the other vector, I had 2, -7, I'm switching signs, and then this component changed signs, okay? Any questions yet? All right, I'm gonna do another one. So we have U in the direction of -1, 4. So I'm gonna sketch it first. -1, 4. And then I'm gonna switch the components and one of them is gonna switch signs. So one of my vectors would have to be -4, -1. And the other one would have to be 4, 1. Right, so let's see if that works out if I sketch it out. So I have -4, -1, right? That's perpendicular. And then 4, 1. Again, that's also perpendicular. So these are the two vectors that are going to be orthogonal to my original vector, right? Okay, we'll do one more. So we have vector V in the direction of √5, 3. So the square root of 5, let's see, what is that? That's about 2.23, okay? So where's my original? So this is my original vector Z. So 2.23 and 3. Okay, so this is my original vector Z. Okay, just like this was my original vector U. Okay. Okay. So to get my perpendicular signs, I'm going to, or my perpendicular vectors, I'm gonna, again, switch the component. So I have 3 root 5 and switch the sign for one of them. So I'll switch 3, or another perpendicular vector would be -3 negative root 5. Right, so here I switch the sign on X and here I switch the sign on Y. Here I switch the sign on X and here I switch the sign on Y. So we'll sketch the 2 vectors. So the -3, 1, 2, 3, and about 2.23, and then 3, and then negative about 2.23. Okay. Okay. So I'm going to write the steps that I want you to follow that I think are helpful. So sketch the vector. Okay. Rewrite it with X and Y switched twice, and then switch one component for each new vector, and then sketch both vectors. Right, so these are some good steps to follow. So sketch your original vector. Okay, rewrite it with X and Y switch twice, switch one component for each new vector, and sketch both vectors. So for example, for this one, z square root 5, 3, I switched, right? So now I have the 3 root 5 and I changed the sign of the X component. Then I switched again and I changed the sign of the Y component. Okay. Okay, so what questions do you have right now? Okay, so what I'm gonna do, I'm gonna push forward in the Nearpod, and I want you to try this right here, and I'm gonna leave my screen up in the Zoom so you have the example, but I wanna see, I'm gonna give you all about 5 minutes to do as much as you can. So I'm going to set that timer for 5 minutes. We'll see how we do, and then we will come back. Go ahead and get started in the Nearpod, guys. I'm really proud of how hard you're working. I like how you're creatively labeling stuff. People are using colors in an interesting way. I like people are playing around with the line thickness in the Nearpod. It's very fun. All right, I think it looks pretty good. Does anyone have questions about this yet? I think people have gotten at least one down. So I just want to make sure the second pair and the third problem, isn't it supposed to be -8, -6? Let's see. Yes, sorry, thank you. -8, -6, because I think I graphed the first one in error. 6, -8 actually goes here, right? So original C is actually here. Yep. And then this is perpendicular, but then, yeah, so this is one, but then the other one is -8, -6. Thank you. -8, -6. Right. 8, -6. Okay. Thank you so much. I'm glad that you were paying attention. Appreciate it. All right, so there we go. So this is not right. This is the original C. I just sketched it wrong. So this is original C, and then we've got perpendicular here and perpendicular over here. All right. Okay, I'm going to move on to the next thing in just a few seconds, but if you need to ask a question, if you need to take a picture, a screenshot, what have you, please go ahead and do that now. Or if you have questions, ask them now. Okay. I'm going to go ahead and go forward then. So the last thing we need to learn, and then you'll practice, and then we'll see if we can play a game, is how do you find a perpendicular component, right? So if you're given two vectors, one is say 12, 48, and the other is A6, how do you find a perpendicular component? Well, you all know that the dot product for orthogonal vectors has to be 0 if the vectors are orthogonal or perpendicular. Okay. The dot product has to be 0, right? So what we're going to do is we're going to take these x1, y1, x2, y2. We're going to take these and make the dot product, set them as a dot product and set that dot product equal to 0, right? So what this means is that x1, x2 plus y1, y2 has to equal 0. So we're going to set that up and make that happen. So for this example, x1 is 12, x2 is A, y1 is 48, y2 is 6, and we're going to set that equal to 0 because again, that is what the dot product needs to equal to make these orthogonal, right? So now we're just going to set this up like an equation. So 48 times 6 is 288. And we're just going to solve for A. So subtract 288 from both sides of the equation. 12A equals negative 288. Divide that by 12, and we get that A should be negative 24. So the value of A that makes these two vectors perpendicular is going to be negative 24. Okay. So we're taking the dot product, setting it equal to 0, and solving for the missing component. Okay. I'm going to do the next one. So I have x1, y1, x2, y2. So I have 3 times 4 plus negative 12 times A equal to 0. 3 times 4 is 12. And then 12 times negative 12 times A is negative 12A equals 0. Subtract 12 from both sides. So I have negative 12A equals negative 12. Divide both sides by negative 12. MAA is going to have to be 1. Okay. If you want, you can check your work too. You could plug it back in and say, is that dot product 0? 3 times 4 is 12. Negative 12 times 1 is negative 12. So that checks out. That's a dot product of 0. Okay. Do one more. So I have these two vectors, negative 4, negative 12, and just A and 24. So let's do it. So we got negative 4 times A plus negative 12 times 24 has to be 0. So we get negative 4A minus, what's negative 12 times 24? Again, this is actually the same as 48 times 6. So minus 288 equals 0. Going to add 288 to both sides. So negative 4A equals 288. If I divide both sides of that equation by negative 4, I should have negative 72. Okay. So negative 4 times negative 72 should equal negative 12 times 24. Okay. Or adding them together should give you 0. So again, to find a value of A that's going to make the vectors perpendicular, we have to set our dot product equal to 0, solve for the missing component. Okay. Any questions at this point? All right, I want to take 5 minutes for y'all to try it. So if you go to the slide in the Nearpod, it will prompt you to do 3 problems of your own. You can use this in the Zoom screen to help you. Go ahead and get started. Ask me questions as you work if you want. You can chat me, you can unmute, but go ahead and get started. All right, I'm looking at some of the answers and they look pretty good, I think. Let's see. Some folks seem to be having some doubts. Just remember, if you divide a negative by a positive or a positive by a negative, that'll be negative. So negative divided by a positive is negative, all right? All right, so if you want to go ahead and look up and check your work, you are more than welcome to. So it looks like the setup is okay. Looks like people's setup is okay. It's just double checking your like order of operations and stuff like that, right? So we've got 12a plus 36.3 equals 0, 12a plus 108 is 0, minus 108 minus 108, 12a equals negative 108. So divide both sides by 12 and you get that a is negative 9. Negative 9. All right. And then for this right here, negative 3a plus negative 927, negative 3a minus 243. Add 243 to both sides. Negative 3a is 243. A is negative 81. And then lastly, with vector u, 1 times a plus negative 12 times 48 is 0. A minus 576 is 0. So a has to be 576. All right. Let's see. All right, any questions about this for now? Okay, I'm going to go ahead and go forward. So if you would just take a moment to open the week 5 homework, the dot product practice. Right, so this is your homework this week. It's just 1 page. All right, so I want you to just take a look at it. Okay, just take a few minutes to scan it. So here you have to find the dot product. Again, using that same formula we've been using, x1, x2 plus y1, y2. Determine if the pairs of vectors are parallel, orthogonal, or neither, right? So orthogonal, remember, we always need that needs to be a dot product of 0. Parallel means they're scalar multiples of each other. And then neither is if neither is okay, right? If neither is the truth. Okay. So you want to find the dot product. If you have a dot product of 0, your vectors are perpendicular. If you see that one vector is a scalar multiple of the other, then those are going to be parallel. And then if neither thing is true, then we're just going to write neither. Okay. And then the last piece of your homework is 9 through 12, just find x if the pair of vectors below are orthogonal. So we've got 2, 4, and x8, 4, negative 3, and x negative 8, 3, 2, and x8, 4, negative 3, and x9, right? So I want you to just take a minute to look at that. And then if there are any if there's a single problem you'd like for me to go over before we move on to our last activity, I'm happy to do that. So go ahead and scan this homework. And if there's any single problem that you think you're going to need some help with, please let me know. You can speak up in the chat, or you can just tell me what your thoughts are. Nothing? Okay. That's totally fine. So in that case, I think what we should do is move on, because we've done all of this stuff. Okay. And before we summarize, I want to try and play a game, and I'm going to play it with you guys. All right, so we are going to play a little game. You can go to this site. I'm going to stop the recording because I don't want you guys to worry about your names. Components of a vector. So we did a lot today. You guys did a good job. I hope you have a good weekend. Do your homework, and I'll see you Tuesday. Number one, and they got swapped for 2.